Hello, Algebra 2 student, and welcome to this lesson on rationalizing the denominator. In this lesson, you'll be provided with problems where you will still be dividing radicals or radical expressions, but it's where the denominator does not simplify to something we like. And so we'll have to do this process called rationalizing the denominator. So without further ado, let's go ahead and get started with doing this method. All right, so here's our first example. And again, I want to thank the people at All Things Algebra for providing all the problems that you're about to see in this video, All Things Algebra. Thank you so much. So what we have here is we have the square root of 8 over 15. Now, the first thing you'll do is just try to see if you can simplify the square root of 8 over 15, but you cannot. So what we're going to do is we're going to rewrite the problem in this way. We'll just draw it like this. So basically it'll be just the square root of 8 over the square root of 15. Okay. Now, what we have here is we have a situation where we have the square root of 15 on the denominator. Now, if you were to do a factor tree for the square root of 15, I hope you know that basically right now it would just be just 3 times 5, and there will be no pairs or anything we can do with that. So because we can't do anything with the square root of 15, what we have to do is we have to do what's called rationalize the denominator, okay? Because a mathematical no-no in this business is we cannot leave a square root or a radical in the denominator. We cannot do that, okay? So the way we do that is simply this. To rationalize the denominator, we're going to take the denominator itself, which in this case is the square root of 15, and we're going to multiply that square root of 15 to both the top and the bottom of this fraction. Now, keep in mind that the square root of 15 over the square root of 15 is just 1. So we're not changing the problem, we're just changing how it looks, okay? And so whatever the radical is, whatever radical that you see, this method, like I said, this is what we call, like I said, rationalize the denominator, okay? So whatever radical you see on the denominator, you can multiply that to both the top and the bottom of our fraction and then try to get that happening, okay? Now, here's what happens. So now that we are going to multiply the radical 15 over radical 15 to both top and bottom, we're simply going to multiply, use our multiplication rules from previous videos. We have the square root of 8 times the square root of 15. So that's going to be just the square root of 120, okay, because 8 times 15 is 120. And then the square root of 15 times square root of 15 is the square root of 225. Okay, 15 times 15 is 225. But what you should realize also at this point is that the square root of 225 is simply just going to be 15. Okay, simply going to be 15. So in other words, to cut the middleman out a little bit, the square root of, when you square root a number times the square root of the same number, it's just going to equal to that number. Okay, so square root of 15 times square root of 15 is 15. But again, if you didn't realize that, you just basically take the square root of 225 and the square root of 225 is 15. But now we got to deal with the square root of 120. So of course, what we'll do is we'll do a factor tree for that. So let me put that right here. So we got 120. So factor tree for 120. So let's see how we can break this up. So we got 2 times 60. For 60, it's going to be 2 times 30. And then for 30, it's 2 times 15. And then for 15, it's 3 times 5. Okay. That's as far as we can go. So because the index on this problem is 2, which I failed to write at the beginning, but let's go and write it now. So since the index is 2, we're only looking for a group of 2s. So we're looking for a pair. And so this time we have a pair of 2s right here. And then everything else is going to be boxed because 2 doesn't have another pair, 3 doesn't pair with anything, and 5 doesn't pair with anything. Okay, so those are our numbers. So now remember that means we're going to come back over here to our problem. We'll write the square root right here. What we have on the inside is 2, 3, and 5. So it's going to be 2 times 3 times 5. All those were unpaired. And then we have that one group of 2s. So that 2 is going to go on the outside. And then the last thing we'll do is simplify this. So we know that we have 2 on the outside of the square root. And then on the inside, it's 2 times 3 times 5. So 2 times 3 is 6. 6 times 5 is 30. So put that right here. And then over 15. Then just make sure that the outside of the radical cannot be simplified further, and it can't because it's just 2 over 15. So you can't simplify that fraction. So therefore, the simplified solution is 2 squared root of 30 over 15. All right, so here we are with our second problem. We have 3 square root of 12 over 4 square root of 7. So again, we see a radical sign in the denominator. It's a square root. So we'll go ahead and just write down, of course, the index is 2. Okay. And so since the radical sign is 7, okay, what we can do is we simply just multiply both the top and the bottom by that radical. So I've already kind of ran out of room right here. So I'll just rewrite it here. So I got 3 square root of 12 over 4 square root of 7. And then we're going to go and put our multiplication here to start rationalizing the denominator. The radical sign here is square root of 7. So we'll put square root of 7 on both the top and the bottom of this fraction. Okay, remember, whatever the radical is, that's what we multiply. And so now to both top and bottom. And so now we're ready to multiply. So on the numerator, we have 3 square root of 12 times square root of 7. So we have 3 on the outside. And then we got 12 times 7. So 12 times 7 is going to be 84. Okay. Then on the denominator, we have 4 on the outside. And then we have the square root of 7 times square root of 7. So that's going to, of course, be the square root of 49. 7 times 7 is 49. But as we mentioned kind of a little bit on the last problem, the 49, square root of 49 is going to be a perfect square. So we can square root 49. So the square root of 49 is going to be 7. So right now on the denominator, we'll have 4 times 7. Okay. And if you want to go further than that, that of course means that 4 times 7 is going to be 28. Okay. All right, so now what we're going to do is we need to go back and deal with the square root of 84. So to deal with that, we're going to just do the factor tree for that. So let's do a factor tree for 84. So here we go. So here's 84. So how can we break it up? Well, let's do 2 times 42. For 42, it's going to be 2 times 21. For 21, it's going to be 3 times 7. Now, since the index is 2, that means we're going to looking for pairs. So we do have a pair of 2s. So we'll go ahead and circle that pair. Okay, so let's go ahead and circle that. And let me take care of that. Sorry about that. So we're going to circle that pair of 2s. There we go. And then we're going to put a box around the 3 and a box around the 7. Okay, because those are unpaired. All right, so now all we have to do is come back to our problem here. Write our square root. So we'll write the square root right here. So we have 3 times 7 on the inside because those are unpaired. And then we do have a pair of 2s, so we'll put that on the outside. That means when we come over here to the rest of the problem, that means we're going to have 2, and then it's going to be the square root of 3 times 7, which is 21. So right now we have 2 square root of 21 over 28. And now at this point, we just need to determine if we can simplify this. Oh, I'm sorry. I'm sorry. I forgot about the 3. I knew there was something iffy about this. So yeah, there was a 3 already outside, right? So basically we got to put a 3 right here. And we also got to put it, yeah, so it'll be 3 times 2. And so 3 times 2, if I move this, change this to 3 times 2 is going to be 6. So yeah, it's going to be 6 square root of 21. Yeah, see, I don't edit anything, okay? So 6 square root of 21 over 28. Let's say I have a different answer on my paper. All right, so 6 square root of 21 over 28. And now we need to see if we can simplify the outside. So the outside of the square root. So we have 6 over 28. And yes, 6 over 28 does simplify. So that's going to simplify simply to 3 over 14. Uh-oh, my pen's getting wacky again. Okay, let me try it again. Let me do this real quick. Okay, see everything going on. All right, let's try this again. So again, it's going to be 3, yep, and then over 14 because that's what 6 over 28 is. And then you put the square root of 21 right there. Okay, and let me move this 14 a little bit and move it kind of towards the center because we really can't do anything else more. Of course, you can leave it like that, or you can, of course, go one step further and just write it like this, 3/14, and then the square root of 21. But again, I'm okay with either one. So either one of these answers is acceptable. So, and you know, this just depends on how the question is asked. But either one of those is acceptable. So anyway, that's how you simplify this problem. All right, so here we are with our third problem for this video. This time we have an expression, a binomial. Remember, 2 terms is a binomial. So we have a binomial over a monomial, which is 1 term. Monomial means 1 term. But anyway, we have just a square root of 12 on the denominator. So what we could do is we could simplify the square root of 12 and kind of go from there. But I think what we should just want to do is just go ahead and just take the square root of 12 and just go and multiply that to both the top and the bottom, and then we can get stuff simplified in just a moment. So so what I'm gonna do is I'm just gonna rewrite the problem: 3 square root of 12, or 3 square root of 2 plus square root of 6 over the square root of 12. And then what we'll do is we're going to rationalize the denominator. So rationalize, we're going to take the square root of 12 over square root of 12. Okay, we're going to put that right there. That's going to make our rationalizing the denominator happen. Now, because the 3 square root of 2 plus square root of 6 is an expression, I'm going to go ahead and put that in parentheses, because what's going to happen is we're going to distribute that square root of 12 into these two terms. Okay, that's basically what's going to happen. So let's go ahead and go forward here. So we're going to start off, of course, with the denominator. So we have the square root of 12 times the square root of 12. Well, as I kind of mentioned before, square root of 12 times square root of 12, it simply means that the square roots were basically going to disappear. So in other words, this is going to be 12. Okay, so it's just 12 on the denominator, 12. Okay, square root of 12 times square root of 12, square root of 144, so it becomes 12. Now we're going to distribute that square root of 12 for the top part of the fraction and try to simplify it. So let's do that. So here we go. So we're going to take the square root of 12 and multiply it to 3 square root of 2. So what is that going to give us? That's going to give us 3, and then the square root of 2 times 12. So 2 times 12 is going to be 24. Okay, so we have 24. Then we're going to do plus. We have the square root of 6 times square root of 12. So that's going to give us the square root of 72. Okay, because 6 times 12 is 72. All right, so now the next thing we'll do is we'll go ahead and simplify this and see what we can do from there. So we'll start with the factor tree for 24. So let's come over here and do 24 for our factor tree. So 24 is 2 times 12. 12 is 2 times 6. We have a pair. Again, the index is 2. Forgot to mention that. But we do have a pair of 2s that we can go ahead and group up. So that's what we'll do. So we'll group up this pair of 2s and then put a box around the 6, because because 6 is 2 times 3, and there's no point of breaking it up further. Okay, so basically we'll come right here and we'll rewrite this. Now we have a 3 outside, so keep that in mind. So we have a square root. We have a 6 on the inside, so we'll put that there. We have a 3 on the outside, and then of course we had a group of 2s right here. So that's going to be 3 times 2. Okay, and we'll deal with that in just a moment. And then we have plus. Now we got to do the factor tree for 72. So let's do a factor tree for 72. So yeah, so 72 is right here. So let's do that. So we're going to have 2 times 36. Okay, and then 36 is 6 times 6. And since the index is 2, we can just stop right there because we do have a pair of 6s. So we're going to go ahead and circle those 6s and put a box around the 2. And that member means we have a group of 6s. So we'll just bring out that 1 6. So now returning to the actual problem, we're going to write our square root symbol. We have a 2 that's unpaired, so that goes on the inside. We have a group of 6s, so we have 1 group of 6. So that 6 goes on the outside of that radical. And then, of course, we still have 12 on the denominator for the actual problem. All right, let's continue to simplify. So we're going to have 3 times 2, which is going to be 6. So it'll be 6 square root of 6 plus 6 square root of 2. We can't go any further than that, over 12. All right. And now the last thing we'll need to do is, last we can try to do is we can see if we can simplify this fraction. Well, you'll notice that there's a 6 on the outside. There's a 6 on the outside and of this one, and then there's a 12. So you have to ask yourself, is there a number I can divide into all 3 of those numbers without getting a decimal? Like, what is the greatest common factor, the GCF of those outside numbers? Well, guess what? It's going to be 6. So I'm going to write down that the GCF, if I can find my work again, there we go. The GCF is going to be is 6. So that basically means that we can divide all those numbers I have an arrow pointed by 6. So that means we're going to write it like this. So we have 6 divided by 6. That's going to be just 1. So it'll be basically 1 square root of 6. I'll talk about that in a moment. Plus divide this number by 6. That's going to be 1 square root of 2. And then the 12 divided by 6 is going to be a 2. Okay. And so the last thing we can really do if you want is we can actually separate this. And so we will go ahead and separate it. So if I can move this down a little bit, it's going to let me do it. Yeah. So basically, what we can have here is we have just 1 square root of 6. So we don't have to write that 1. We can just simply write it as just the square root of 6 over 2. So that's what we'll do, square root of 6 over 2. And then plus, and then again, it's a 1 with a square root of 2. So again, we just write the square root of 2 over 2. And so this is probably the answer I would probably prefer, that you write it like this. But yeah, that's it. So again, it still works to rationalize the denominator. Like I said, it still works to rationalize the denominator. Just make sure that you you know, multiply both the top and the bottom by that denominator, and then get it simplified using this distribution, and then of course simplifying with factor trees. All right, so hopefully that helps you do some rationalizing denominators. I hope this will help you do that as you do problems like this. Stay tuned for another video coming up real soon, where it gets a little more complicated and we'll still have to do kind of like rationalizing the denominator. But in the meantime, thank you for watching. Hope you enjoyed it and look forward to seeing what work that you can do for this. Take care and stay safe.